Good morning to all. Looks like the 11 o'clock hour has come, and just like to welcome you to the next session in our webinar on cybersecurity. And today's session, and I'll make this short, is hosted by Claroty, and Mr. Gary Nealon's going to be the presenter from Claroty. And for anybody who's not aware, this is a solution that really addresses a lot of security and deep packet inspection on the OT side of the network specifically. And it's really kind of a crown jewel of securing that OT system. And we're going to start with a little bit of a explanation about what the system is, a little bit of demo, which is going to be a live demo of how it works. And then at the end, we've got some time for some question and answers. So jot down some questions as it goes and make sure we get those answered at the end as well. So with that said, I'm going to let Gary take it away. And again, welcome to the seminar. And just a reminder, these are all recorded. So if you would like to show those or share them with other people who couldn't attend today, those will be available, and just ask us for a link of where those are, and we'll make sure we provide that to you. Thanks, and take it away, Gary.
Thanks, Robert, and happy to have the opportunity to come and talk to you guys and to work with Rexel on securing these important critical systems within operational environments. So as Rob said, I'm Gary Nealon. I'm one of the principal product managers here in Claroty. Come from the OT space. I've been doing OT cybersecurity for probably close to 20 years now, which is surprising it's been that long, but initially was a system engineer at a nuclear power plant in Washington State. Kind of got into security when the regulatory regime passed on cybersecurity for OT systems there. And then have since moved into consulting with Schneider Electric, and now I've been at Claroty for the past almost 9 years. So today I'm going to be going into kind of why Claroty exists, right? Why we need a special solution for this space, specifically targeting operational environments. And as Rob said, I'm going to be going into directly into a demo itself of the system to kind of walk you through. So I just saw a chat. Someone said they couldn't hear me. I guess just check really quick, Rob. Can you hear me okay? Or can other folks hear me? Just want to make sure my sound is okay. I know we tested it before. Well, I'm going to assume that we can. Okay, awesome. We can hear me. Great. Sorry for it. I had some issues with the WebEx thing myself. Maybe quit and rejoin, and that'll get you going. So let's go ahead and jump right into it and talk about kind of why we're even talking OT cybersecurity, right? Why did this happen? I think for a lot of folks that have been in this space for a long time, it's something that's pretty new. It's something that's really come in the last probably 5-10 years. And we have a lot of things that have kind of forced us into this space. So the first is we're having more and more connectivity, right? You're going to be hard pressed to find any facility nowadays, production environments, manufacturing sites, power plants, chemical plants, oil and gas, whatever, that doesn't have some sort of network footprint, that doesn't have some sort of connectivity. And more, we're connecting these systems up to do a whole wide variety of things, right? Whether it's business monitoring, whether we're doing reporting, whether it's for remote access or things like that. More and more, we're moving these workloads that used to just be completely standalone in these operational networks onto the IT network, or we're at least exposing them into the IT network because we have to do these functions within the system. We're also seeing more and more threats, right? I think everybody probably remembers Stuxnet from way back when we're seeing, targeted nation-state attackers on OT equipment. But we're seeing more and more attacks happen in this space, right? We're seeing people both target OT environments directly. We've actually seen a lot of that with like Ukraine and Russia. We've seen targeted attacks on critical infrastructure and things like that. But we've also seen more opportunistic things, right? Ransomware, things like that are either targeted towards an organization or leaked over from the IT network because, again, more and more of these systems are connected. So you have a path from your IT network down into your OT network. Also, we're seeing a lot more regulatory pressure. I don't know what industry all you guys are coming from, but in critical infrastructure across the US and globally, we're seeing a lot more governments take notice. Things like midstream pipelines very recently started getting regulated by the TSA after Colonial Pipeline. We're seeing more and more push for that in Europe right now. There's the NIS2 requirements that's starting to have more and more regulatory pressure on critical infrastructure. So I think this is going to continue shifting in this direction. We're going to have a continued push in this, which forces us to have some sort of solution, right? We need to have something in place to start dealing with these challenges. The other big thing that we have is that disruptions are starting to increase. I think when you look into the C-suite, more and more organizations understand this is something they have to worry about. If we look at just by the numbers, 95% of CISOs in critical infrastructure are now starting to adopt these requirements. You know, they're not just over these IT networks, they're also taking over the operational environments as well. We're also seeing a huge number of organizations, 75% of industrial organizations are having some sort of ransomware in their environment, again, whether it be targeted or an opportunistic attack or just a random, you know, poor network architecture leads to something leaking over from the IT network. And then we see organizations, these attacks are spreading to more and more locations, right? 55% of these organizations showed that it was a multi-site impact. So things that used to be very, very local, again, we used to be talking about security at a single site, now can very easily go out to a fleet, especially when we're talking global WANs and these large footprints that larger organizations have. And we're seeing a lot more organizations have larger costs associated with this, right? So there's a lot of drivers, both from the business and from just the landscape we're seeing that lead us down this path to needing some type of solution in this space. Again, I spoke a little bit before, but there's a lot more regulators coming into the space. Again, if you guys aren't regulated, great, but especially if you're in a critical infrastructure space, I think we're going to see more and more of this. And having come from a space where it's regulated, it really does shift your priorities. You know, you care a lot about meeting those requirements and making sure that you can pass an audit and that you're going to be able to continue operating. So why do we need something different, right? Again, security is not a new thing, right? We've been doing security in the IT space for tons of time, right? Everybody has their programs in place. Every organization has their patching, their incident response, their disaster recovery, right? Everybody has their programs in place for this. But the operational environment is just different. It requires a different approach. So if we just look at some of these high-level things like the landscape of assets is significantly different, right? In the IT side, you're looking at servers, switches, laptops, you know, corporate type devices, things that are fairly standardized and modern. On the OT side, you have cyber physical systems, right? You have PLCs, HMIs, engineering workstations, sensors, pumps, motors, drives, things that are doing things in the physical environment. These both operate very differently and have different controls that can be applied to them. You know, you can't go patch PLCs on a weekly basis like you can go Windows system. The other big issue here is in IT environments, confidentiality is the number one thing, right? We care about protecting our business data, about protecting personnel data, you know, those types of things are highly critical. On the OT environments, safety, reliability, availability, those are the number one things. Whatever we do with our security system, we cannot be taking out production. This is what makes our companies money. These are the things that are critical for the operation of our business. And we need to make sure that whatever we're doing is keeping that in mind and keeping things running while keeping them secure. The other big issue here is protocol coverage. Again, on the IT, things are pretty standardized. You know, if you're going to do a web server, there's only a couple of flavors out there. If you're implementing new databases or whatever, right, it's a pretty well-trodden area, a lot of windows. On the OT environment, it's very different, right? All these PLCs and these operational equipment are using proprietary devices from the vendor. Rockwell is different than Siemens, which is different than Schneider and everybody else, right? They all use proprietary protocols. They all use their own operating systems, their own methodologies. And you need something that can understand this very diverse area, or you're going to have big blind spots. If we don't know what's there, you're not going to be able to properly secure it. Last couple of things here is, again, in IT, security is pretty well known. If I was to ask you, hey, how am I going to go do, EDR in the space on your IT environment? There's, again, a handful of vendors. You know what they are. You're probably already using one, right? You're using Microsoft Defender or CrowdStrike or something like that. It's a very well known space. On the OT side, we can't do that, right? You can't run an EDR on a PLC. You can't run that on one of your sensors or your pumps or your drives. So we need different things to focus in that environment, again, because you cannot take these IT systems and take them down into the OT space traditionally. The last thing here is just compatibility. Again, everything on the IT side is built to take advantage of these security controls that we've been building for the past, 15, 20, 25 years. That did not happen on OT. The fact that we're even talking about this now, security is a very new thing in the operational space, which means vendors are not, at least not in the past, thinking about this and trying to have commonality between equipment and things like that, right? We didn't have a convergence on things like Windows and security solutions like we did on the IT side. So that is a big concern. The other thing is that, a lot of OT practitioners probably have seen things like you go run Nessus in your OT environment and you take out a bunch of devices, or you go run a, Tenable scan or something like that, Qualys or whatever, and you start having issues. It's because they're not designed for this environment, right? They're not designed to communicate with these devices in a safe way. And it can lead to operational interruptions, which again impacts our bottom line. That's what's actually producing us money for our businesses. So the other big thing is that we see the current approach to the cybersecurity for these systems kind of falls short. We're trying to leverage IT solutions. A lot of times you're incompatible. You can introduce new risk. You see this a lot where companies try and take their IT solutions and move it down into the OT environment and end up with outages or interruptions to production. We also have very antiquated asset discovery. I think most companies, come into their OT environments, they don't necessarily know what's there. They don't know what's on the networks. There's a lot of gaps in that inventory. And getting that is very challenging because you have a very diverse set of different devices that talk in a very diverse set of protocols and require different methods to gather information about them. All of this leads to lack of actionable insights, right? If I don't know what's there and I can't get my information on it, I can't figure out what I need to do. If I don't know what the problem is or my starting point, it's going to make it incredibly hard to operationalize any type of security program because I don't know where I need to go put an alternate control. I don't know where I need to go patch something or do things like that. The other big thing here is we see a lot of customers trying to stitch point products together. It becomes very, very complicated, especially in these types of environments where for any mid or large size business, if you look at your operational sites, they are not cookie cutter. At least for most organizations, they're not super cookie cutter. You're going to have different things between different facilities. You're going to have different solutions required. You're going to have different architectures. And having something that can maintain that from a single place becomes very important, again, just to make it so we can scale and we can do this at the level that is needed to meet your business objectives. So that kind of leads to where Claroty exists. So again, Claroty, we've been working with Rexel as a partner here for deploying our solutions. We've been around for a while, closing in on 10 years now. Our big focus is operational systems, right? We are an OT company first. We have expanded since just doing, our roots are all in things like manufacturing, energy, utilities, oil and gas, all your favorite critical infrastructure stuff. We have been expanding in the past few years into commercial buildings, so building management systems and things like that, and in healthcare facilities. So we've done a lot of recent work on that front, moving into the healthcare space, but we're focused on that area. The company came from that space. If we look at some of the capabilities, I'll run through some of these as we go in the demo, but it's really about identifying assets, getting that inventory, reviewing the system for exposure and risk, ultimately doing threat detection, real-time threat detection on attacks in the environment. And we also have a secure access platform to be able to do remote access into the environment. Won't go through everything here, but you'll have the recording if you want to go see all of our accolades and our strategic alliances and things like that. The other thing here I wanted to touch on was some of the broad strokes on what we're doing. again, exposure management, we really focus on being able to identify where attackers could leverage into the environment. Just coming from this space and having worked at a lot of different facilities, it's very challenging deploying mitigating factors into these types of systems, whether it's putting in network controls or trying to put in other security solutions or things like that. So we want to be able to make sure whatever we're doing will have the most bang for the buck, is gonna move the needle the most. So that's a big focus area for us. Network protection, I think, is a huge one as well. I think a lot of customers want to be able to do network segmentation projects or do restricted VLANs or things like that. And we really focus on that with our products. So I'll show this through the demo here. We also have a separate platform that we do secure access on, which is built around remote access for local users or third-party users accessing into the OT environment. It's really designed for these types of networks where you have restricted data flow requirements or items like that within the environment. And finally, real-time threat detection. I think this is a big piece of the puzzle. We want to make sure that we can identify if someone's in our environment and doing something so that we can actively stop them. All of this is kind of underlaid by a comprehensive asset inventory, which again, I'll show off in the demo. I think that's the number one thing. We want to make sure that we can identify what is there so that we can effectively respond and take the appropriate actions when we're looking at security solutions or anything like that. So that is a lot on kind of why we're here, what the Claroty mission is, a quick overview on why Claroty exists. Again, we're built for this space. We have the operational roots. That's been our entire mission the entire time. We're not taking an IT solution and trying to put it into the OT space. This was built from the ground up as an OT solution. But with that, we will see if I can successfully switch my share to my other tab. Looks like it did it. So with that, I'm going to show off our on-premise solution, which is the Claroty Continuous Threat Detection Platform. So we have two flavors of this. We have what I'm going to be showing here, which is our Continuous Threat Detection Platform. And then we have our SaaS flavor, which is called Claroty X-Dome. At the end of the day, they're both doing very similar things, right? They're, I talked through some of the value cases here, but it's really about identifying assets, figuring out existing risk, vulnerabilities, and exposures for those assets, gathering information about that. Then we also do real-time threat detection if an attacker's in the environment, and doing investigation and things like that if we're trying to do threat hunting or looking for where an attacker could leverage into our environment. So between our platforms, they're similar. Obviously, X-Dome we're managing. The CTD platform that I'm going to walk through today is something you guys can deploy and manage on your own, or have a partner like Rexel, help you with the deployment and get this out there and help operationalize it. So from this, again, this is kind of our dashboard. It gives you a view on kind of how we're doing, gives you a number of assets, things like our alerts that we're seeing, our top insights, which I'll dig into more detail. Hygiene score, which is kind of a global view of how am I doing, right? Am I doing red, green, or yellow? When I talk just my cyber hygiene for my operational environment. So we try and create these types of KPIs so you can track this over time and see how we're doing, gives you an idea on some of the changes you may want to make. But the starting point here really comes from visibility. So again, when we first come into an environment, there's a number of different ways that we can deploy. The simplest way is where we basically get a span port or a mirror or monitor port from a managed switch within the environment. So if you've heard anybody talking about like passive data acquisition or something like that, that's what this is. It's a span port. All it does is it sends us a copy of the traffic that is going within your OT environment. What this allows us to do is it allows us to look at that traffic, figure out what's going on in it. We do what we call deep packet inspection, where we investigate this traffic to look for assets, to look for alerts, to look for information about those assets, to figure out how they're configured. So all of this can be done passively, which again is very, very simple. We call it a site or a sensor. We put it on the location. We get a copy of traffic within the environment. And that is the simplest deployment option. It's very, very safe as well. By being passive, we don't actually have a link back into the environment. So it is totally transparent to your operational equipment. It doesn't pose any risk to any of this environment from a safety point of view or availability point of view. You just have to reconfigure some switches, send some data to us, and we're able to do all the things that I'll show through in our demo today on that. We also have other ways of deploying. So we've recently gotten into what we call our safe active queries. So instead of relying on passive data, we can also query assets directly for additional information. This is not required. You can choose to do this or not. But the difference between us and, like, again, an SS or a Qualys or something like that is we talk to these devices in the same protocols that they are designed to respond to. So we're hitting a Rockwell device over SIP or Ethernet IP. We're hitting a Siemens device over S7. If you look at it from a network point of view, it is indistinguishable from engineering workstation traffic. So it looks the same as if you pulled open an engineering workstation and hit one of these devices. The benefit of this is it gives us a lot more information. It allows us to get a lot of detailed data about these assets. And again, it's all done in a safe way that is intended for these operational environments. So those are a couple of the ways that we deploy. We also have some other tools in the tool belt, but just in the interest of time, I'm not going to get into all of them. But again, everything I'm going to be showing off today is achievable through our passive data link, which is, again, the simplest, safest way of deploying. All we need to do is set up a spam port, feed us a copy of traffic, and be able to ingest that within the system. So again, the first thing we're doing is gathering configuration information about these devices. So you can see here, I've already identified a lot of different devices in here. This is our lab network where we do a lot of our research. And from this, you can see some of the configuration details I'm grabbing. So things like IP address, MAC address, what type of device it is, right? PLCs communicate a lot differently than engineering workstations or HMIs or things like that. And so we'll automatically tell you what type of device it is, what vendor it is, and we cover a very, very wide variety of operational vendors. I think that's one of Claroty's biggest strengths is that we cover more protocols, more types of equipment than I think anybody else in this space. So when we come into your environment, we should be able to cover everything that exists. And then, again, high-level things like criticality and risk level. But let's dig in and look at some of the more detailed data that I can get for this device. So here's that PLC that I was showing off before. And I can show you some of the same stuff I showed on the previous page. Things like its IP address, its MAC address, the type of device, those type of things. But we also get detailed configuration information for this device. So I can actually get what its current firmware version is, the model number of this device, and the serial number for this specific PLC. I'm also able to get what mode it's in. So whether it's in run mode or program mode or stop mode, we can also identify that to show you, hey, are we trying to keep our PLCs in run mode so they can't be programmed? We have that available within the system as well. But that's just the starting point. So this gives us a lot of good information on the head level of this PLC. But let's actually go into even more detail. So this is a Rockwell control logic. So it's a card chassis type PLC where you can have a bunch of different slots that do different functions. And we're able to enumerate all of those slots to show exactly what's installed. So if a slot doesn't have anything in it, we'll actually show you that slot is empty. If a slot does have something, we'll show you specifically what exists. So the model number, serial number, and firmware version for that specific card. So this gives you a huge amount of detail of what exists in these environments. And again, I was a system engineer many years ago, and having this outside of an Excel sheet that you have to walk down and try and manage manually, this is a huge boon to our engineering friends. It makes it so much easier to manage the environment when you're getting all this data automatically. And you don't have to worry about if someone goes and plugs a new device into the environment or something like that. This will automatically get updated. We're constantly looking for new devices as they come online, as they get changed, as configurations change. So this is a living inventory of what exists in the environment that is updated in real time. We're also able to identify nested devices. So if you have things like serially connected devices, drives, I/O cards, again, pumps, motors, things like that, we automatically can identify those as well, even when they're nested behind a PLC, which is very, very common for a lot of different PLC vendors. So Rockwell does this super heavily. It's very common where you have a PLC as kind of a head end for a network behind it. We can identify that and enumerate that data as well. Even more depth here, in this case, I've actually seen a configuration upload occur to this device over the network. So I saw someone change its config while it was plugged into the network, and I actually identify that config and pull it out here. So this is the actual programming code that is logged onto this specific PLC. So again, we're getting really, really deep detail on this device. It's giving us all the information on exactly what's there, how it's configured, all the things like firmware versions, model numbers, serial numbers, so that we can have every bit of visibility information that we need for this device. So this is a great starting point, right? This is amazing detail, you know, and this is something that is possible for us to get passively, right? If I see the right traffic to this device, I can gather all this passively. This is also something we can gather actively if we want to, but this is something we can get totally passively. What are we doing with this data, right? I've got this great visibility information. It's amazing. I have all this detail on this device. Well, this is where we come into our risk and vulnerabilities. So now that I know exactly what this device is, I know how it's configured, I know all the detail about this specific PLC, I can give you a granular risk score on this device. So we calculate this across every device within your environment. We look at both what it is, how it's configured, who it's communicating with, what types of communications it's doing to other devices. You know, if it communicates to the internet, it's significantly riskier than other devices that don't. So we pull all this together to create a very granular risk score of this device. We also create a large number of what we call insights, which is basically anything that's interesting or you would want to know about this specific piece of equipment. So the first thing here is CVEs or vulnerabilities for this device. So just like in Windows, where Microsoft publishes vulnerabilities all the time and other organizations do about vulnerabilities on Windows, this happens now with operational manufacturers as well. Rockwell, Siemens, Schneider, Emerson, you know, all these guys are also doing threat research. Claroty actually does a ton of vulnerability research against operational devices. And you're seeing more and more vulnerabilities get published against this equipment. So now that I know exactly what this is, I can tell you exactly what vulnerabilities are applicable to this specific device. And then I can give you more information about it, right? For this specific CVE, what's the CVSS score? When was it published? Some more information about it on how this vulnerability can be impacted. In this case, it's over the network. We give you information on the actual publishing agencies. So in this case, I can go over to CISA, which I actually don't know if the share came over. There we go. So if I look here, I can see this is the CISA overview, right, of this specific vulnerability, all the products, what it impacts, what I need to do to respond to it. So I get all this level of detail on what this vulnerability is, how it impacts this device, and what I need to do to remediate this specific vulnerability. So we get all of that information against this, again, because of that deep level of visibility that I have for this piece of equipment. We're also looking at non-security related things. So in this case, this is an end-of-life asset, right? Rockwell only supports assets for so long. So we actually look at, for this specific device, whether or not it has cards or modules in it that are approaching end of life. For a lot of customers, they use us to do lifecycle management for their operational areas because we're automatically identifying all this equipment, and we can tell you if, again, Rockwell or Emerson or GE or whoever was saying, hey, we're only going to support this through XYZ date. After that, you know, you're on your own. We automatically are identifying that information as well. In this case, I'm also looking at a number of other things like what users are actually managing it. So again, I've seen configuration changes and engineering workstations actually hit this specific device. So I can tell you who the users were that were hitting this. This could be very important if you're trying to audit who had privileges against this device and whether they were supposed to have privileges against this device. So we get a ton of detail here. We're getting a lot of information. And this is just for one specific device. If I zoom out a little bit and look at this across my entire fleet, you can see across this site a bunch of data that I'm grabbing for all the devices in the environment. So things like unpatched vulnerabilities or those CVEs like I was showing before, we show this across all your assets. You can get all that in a single place so that we can work that list and start evaluating those and changing that. Again, if we need to patch systems, put in alternate controls, whatever it is, we want to be able to identify that so we can start reducing risk. Again, things like end of life, we look for any devices communicating directly out to the internet. If we see stuff talking with external IPs, in a lot of cases, from an exposure point of view, this is one of the #1 things we want to go evaluate. If we don't think we have devices talking to the internet, we really want to know why we have stuff talking out to the internet, especially if you have firewalls in place and you think it's not talking out there. I've seen a lot of operational environments where the best firewalls are defeated by a system engineer with a Linksys router who just wants to throw something in there so they can get to a device from home. It happens a lot more often than you'd think, especially in a lot of these operational environments. So we want to be able to evaluate all that and tell you exactly where it's happening so that we can start taking action against it. And again, we're looking at a number of other things like unsecure protocols, right? Are we using FTP instead of SFTP? Are we using SMBv1, which if any of you guys got hit by WannaCry, that's SMBv1 is the favorite path for Eternal Blue. That's how it gets its way through the network. So if you have thought that you've removed SMBv1 everywhere, we can validate that for you, right? We can show you exactly where it exists or if it still exists within your environment. So again, we can make changes. We can go turn that off and disable that within these devices. So this is that idea of insights where we're coming in and looking at this across a bunch of different metrics for both operational equipment and for potentially other equipment as well. Again, if we have servers, switches, Windows systems, things, those types of devices, we're also looking at these types of insights across all of that. So the things I've shown on so far, this really gives you the information you need to start proactively working on risk and exposure and those types of things within your environment. We give you that inventory, we give you all the detail on what exists so that we can start making those changes proactively, right? If we're patching systems, if we're disabling unsecure protocols, if we're setting up better network controls and removing internet connectivity, all that stuff is designed to stop an attacker before they come into the network, right? We're removing pathways that they could use to get into the network or to leverage devices if they do get into the network. So this is all stuff that you can use to start proactively fixing stuff before a bad guy gets in the environment. But we're also doing that real-time piece. Again, we're looking at real-time threats, real-time attacks within the environment. And that's where our threat detection comes in. So this is where, unfortunately, bad guys gotten in and we need to be able to identify what they're doing, how they're doing it, and how we can stop them if they do come in real time. So this is where our alerts come into play. This is where we're alerting on a whole wide variety of items here. So we're looking at things like known threats here. This is any of our signature-based alerting. So you can see some examples here of things like Eternal Blue, WannaCry. If we see classic IT types attacks of things like ransomware, botnets, malware, any of the known, command and control traffic, any of the bread and butter type IT attacks. We have a whole host of signature-based detection that we use with both Snark and Yara, where we look for attacks with these types of signatures. So this is looking, again, for the classic attack that you would see, or if we see something in the IT network start working its way into the OT environment, a lot of times we're finding it through these signatures because it is things that have existed before. We've seen these types of attacks before. This is also something that Claroty maintains for its users, so we're continuously updating this. We create a curated list of these signatures that we do based on risk and noise to make sure that we're giving you the most actionable alerts within the environment. To show anytime we do give you an alert, we want to make sure that it's something that you can go do something with today, that it's not going to give you a false positive or anything like that. So all of these known threat alerts are, again, stuff that we know that's out there, stuff that we know that's bad, and we can identify within the environment. But we also want to look at, potentially day zero type things. So these are things like new asset alerts or policy violations. These are where we create a detailed baseline of how devices communicate with each other, how that normally occurs within the environment, and then we alert if we see new communications. So like here's a great example where we see a policy violation between two assets where we're seeing telnet that has never been used before. So why does this matter? Well, first of all, telnet's a totally unsecure protocol, right? It is something that goes in clear text. It's not secure. So something we don't want to be using in our network if we can avoid it. But if we see devices talking telnet that have never talked telnet before and it's not a part of their normal communication pattern, we really want to know about that because that is classic attacker type behavior, right? They're coming into an environment, they're poking around with protocols that they know about, default protocols, unsecure protocols, those types of things, so that they can look for holes or areas where they can leverage devices to, again, impact operations, to try and exfiltrate data, to try and inject a payload or that sort of thing. So this is where we alert on any of that new type of communication to show you that. And again, in this case, we've created that detailed baseline of how these devices normally communicate, and we'll be able to show you when any new communication happens. Again, in this case, this device has gone out and hit telnet on a bunch of devices in the network. And we can see that whole history here of when they started doing that, when they started crawling the network and hitting a bunch of equipment with this new protocol. So we identify that because we've never seen this behavior before. And this looks very abnormal, right? This looks like someone got on this host and they're crawling the network trying to find a place that they can impact a device. That is why we create this root cause analysis, so you can see all of this in a single place. I can see the history of events here. And again, in a case like this, where maybe a single telnet thing, oh, we installed a new program or something like this, this looks very abnormal and potentially very malicious because you have this single host coming out doing a bunch of new behavior all at once in a very shady type scenario, right? Again, because they're using telnet, which is an unsecure protocol. This looks very abnormal, and this is the type of thing that we would want to go investigate to look if we see, if we need to stop this device or do something else. You'll also see we show mitigation steps in here. So not only are we grouping all of these complex events together, showing you a visual graph here to show how this looks throughout your environment, but we're also giving you mitigation steps on what you can do to go prevent this, right? Do we need to go contact IT? Do we need to go raise a ticket somewhere? Do we need to go take this device offline or something like that? We try and give you that information so that we can take those steps when we're responding to an alert. Another couple of examples here I wanted to give out quickly was config download. So we're not just looking at alerts on security specific things. So again, things like our signature-based security alerting and a lot of our policy violations, those are classic security events. That is usually a bad guy in the environment doing something very bad guy-y, right? Something super malicious, really obvious to identify as malicious, as long as you got the Claroty smarts to be able to identify it. But it's behavior that we're not expecting in the network. We're also looking at events that could impact operations, but aren't necessarily malicious. So a great example of that is configuration downloads. So this is when I'm pushing a new config to a PLC, and we alert on any event that can change how a PLC operates. So this is configuration upload and download, firmware changes, mode changes, online edits, any of these events that can change the code on a PLC or stop it from doing its functions. Again, this may not be malicious. This could be a totally valid engineering thing, but it could also be something that could easily take down a facility and stop production because somebody changes how PLC is operating. So in this case, we alert on this guy. The reason we're alerting on this is that we've never seen configuration downloads occurring between these devices, so it's not a normal engineering workstation. We also show here this history of events to show who's doing these config downloads, when they occurred, and all that sort of data. We actually show you the assets involved. So this 10.1.30.40 is the guy that was performing the config download on chemical plant, which is our PLC that I was showing off before. So I can see who the devices involved were. And then I also show the actual config change itself. So if we do need to respond, if we do identify, hey, this looks malicious and I need to go take some steps against this, I need to go try and stop this or do something to prevent this activity in the future, I actually get the code that was changed as a result of this config change. Remember I showed before in the visibility that I actually captured the code that was there. So I can look at this and I can actually show a difference of what lines of code actually changed as a result of this as well. So if you were to come in here and look, I could view this configuration. I could look for specific, what specific lines of code changed as a result of this. It makes it very quick to respond and to be able to take the appropriate action against this. So this shows a bunch of different examples of alerts, right? We're not just looking at the strictly malicious stuff. We're also trying to capture anything that can impact the operation of these facilities. So we're pulling in a lot of different stuff, and this really talks to kind of the OT roots of Claroty. We're not just looking at those classic IT attacks, which a lot of IT solutions do. We know in context for an operational environment, if you're changing firmware on a PLC, that's usually something you want to know about. It doesn't happen all the time. It's something that we want to be alerted about. We want to make sure it happened in the right way. Typically, it's going to be associated with the work process, right? We're going to have a work order. We're going to have it planned in the plant. So we want to be able to capture all this information and give you that context so you can appropriately do security against these operational assets. So I know I just have a few minutes left here before we got to dive into the Q&A, so I wanted to show off one last thing here. So everything I've shown so far, these are kind of the broad strokes use cases that I was talking about before. Remember, we want to identify all those operational assets regardless of the vendor. We want to get detailed configuration information on those assets, exactly how they're configured, what model number, firmware version, serial number, all that level of detail on all of these assets that we identify. With that, we want to give you those risks and vulnerabilities. Again, if we see CVEs, if we see abnormal data, if we see configuration issues, or other things like end of life or any other potential impact for that device within your space. Then we want to do that real-time alerting. We want to look at the real-time bad guys in the environment now. How are we going to respond to that directly? The last thing that we have for CTD is what we call our investigation feature. So I won't dig into all these, but these are really our threat hunting type things. So again, for any of you guys that are true, SOC nerds or guys that live behind a Splunk dashboard all day, or any guys that's running a SOC or a NOC, you guys are not just wanting to respond to alerts, right? You want to get in there, you want to look at the environment, you want to understand what exists so that we can try and figure out, are there other things that we can be doing, right? Maybe there's other indicators of compromise that we need to look for to try and identify if an attacker is in the network. So this is where all investigation features come into play. This is where I can look at a bunch of different metrics that are key for operations that we can go in and look at in this environment. So simple examples here are like DNS queries, right? Typically, we don't have internet access in these environments, so we want to look at all the DNS queries that we're seeing just to make sure, again, if you think you don't have internet access, but you're seeing a bunch of DNS, something's wrong. Either you have programs trying to reach out to an update server and it's being blocked by a firewall, or maybe you do have internet access. I've actually seen operators, plug a phone into the create a hotspot on their operator workstation so they can go out and browse the web. That's stuff you want to know about. That's stuff that can very quickly break your security program. So we want to be able to look at that and look for some of these abnormal indicators. We also are looking at things like process values. This is actually looking at the values being written to and read from the OT space. So like in this case, if we're writing to specific registers in Modbus, setting pump speeds or tank levels or things like that, we're actually identifying these. We're looking for changes against it. We're looking for abnormal changes so we can see if somebody sets a value to something way out of whack or something not expected. And again, some of these items, things like our network sessions and looking for who's communicating with who, what devices are actually doing the most communication. You can very easily see who your top talkers are. If you have a network area where you have issues, maybe you're running over a T1 line and you only have so much bandwidth to play with, you can really quickly diagnose who is taking up most of the link. So you can, help fix any network saturation problems that you may have into more remote areas of your site, or areas where you're getting a bunch of retransmissions, right? If you're having a bunch of network failures, we can quickly identify that. And I've seen a lot of facilities where you look at this, you start investigating some of it, and you may find broken network configurations that you didn't even know about that can really help, again, outside of the security space, it can really help operationalize your plant. So I've gone through a lot of stuff. The last thing I'll really quickly touch on is that everything that I've shown before is all reportable, right? Your data is only as good as what you can show off. So we do have reports. We have a bunch of canned reports baked into the system already. We also have a reports editor where you can create your own reports. You can create very fancy visual reports. Great for a CISO or a board, lots of pretty charts and graphs and those types of things. So all of that data can be captured out of the system and sent off to whoever the appropriate stakeholder is. So with that, I think I promised I'd give time for some Q&A at the end. So I think actually...
Yeah, Gary, we've got a few here.
Yeah.
First one, this is a head scratcher for me. Can you identify serial devices behind a Digiport server that converts serial to Ethernet?
As long as you're seeing the Ethernet traffic, yes. Like we have like Modbus, TCP, HART, and other serial to Ethernet protocols. So as long as it's on the TCP side, yes, we definitely can. For more complicated setups, so for things like where you have serial devices, like again in that Rockwell example, if you have devices talking on DeviceNet or ControlNet, which is a serial protocol, we can actually route down to that. They have a function, a TCP/IP function, where you can send data to the PLC and it will convert it to serial messages to those devices. So that's what allows us to get other parts of serial networks. So depends exactly how your network is set up, but yes, in a lot of cases we can. We know that's a lot of plants have a lot of serial stuff, so we want to be able to cover that as best as we can.
So it's probably kind of safe to say it's the more common serial devices. There's possibly identification for it. And whatnot,
yeah, absolutely. And even in complicated environments, like there's a lot of stuff we can do there. So that's why we have lots of fancy sales engineers and post-sales guys that can help deploy and look at your guys' environment.
Okay, here's another one. Can Claroty access functions in the PLC program if it's password protected?
That's a great question. So the default ones, we will, if we're doing active queries on these devices, we will attempt the default passwords. So in a lot of cases, even when it's password enabled, like folks use the default ones. In some in particular, there are hard-coded default creds that we leverage. So I'm looking at Foxborough, if anybody knows the Fox Gnomes password.
Yep.
That was a fun one when I was at Schneider Electric. So we do attempt some of that stuff. For any authenticated query, if we're doing active, we do allow you to put in those credentials, so you'd be able to do an authenticated query against these devices. And of course,
And
if we
normally
see it passively. Oh yeah, go ahead.
and normally it's kind of safe to say you're really monitoring more at the Ethernet level of what's going in and out of that controller anyway, right? So it's
Yeah,
not
absolutely.
looking for
And if we were to see it passively, we would, in the most case, those events happen in clear text. It's just the nature of these protocols. So when we see that happen, we'll pull that config out.
Okay, can communication patterns be used to build firewall rules?
Yeah, absolutely. That's probably one of our biggest integration points. So we create what we call, I didn't show this off during the demo, but we create what we call zones and policies. So it's very similar. If you're familiar with IEC 62443 and the idea of zones and conduits, it's very, very similar to that. Here, we automatically create zones for our groups of devices, and we create communication policies for how they normally communicate based on what we've seen. This can be sent up to a firewall through one of our integrations to be able to create restrictive firewall rules if you want to restrict based on the traffic that we've seen.
Okay. Another one is Claroty installed on each HMI or devices, or is it on-premise or cloud-based?
No, so what I've been showing off today is CTD is on premise. So usually there's going to be a physical or virtual server sitting at each physical site. Like usually each campus will have a Claroty server at it. It could be physical, it could be virtual. If it's SaaS, again, it would be the same. You would have a physical or virtual server to do the local data collection. In the SaaS case, it goes up and talks to Claroty Cloud. In this case with CTD, it would talk up to what we call our enterprise management console, which you could host in your own infrastructure in a corporate data center or something like that. A lot of times customers host it in a private cloud anyways. So that's how we normally deploy.
Okay. Can you see the same level of detail on non-Rockwell systems, i.e. Emerson and PAC?
Yes. We have support for Emerson. Be happy to share with you a full protocol list. Again, I'm pretty confident to say that we cover the widest variety of equipment that's out there. We've been doing this for a really long time, and normally we're seeing, across all the facilities that we've installed into, we've seen probably everything that exists out there. Most stuff outside of like, you go to some small European country and they may have a local device manufacturer that only exists in Europe. If we see that, we add support for it. So for any of the big vendors, again, like Emerson, Siemens, Schneider, Rockwell, GE, whoever, like those big guys, we have full support for all that.
Yeah. It's also important too, I'll say from my standpoint too, it's Claroty's funded by a lot of those companies too. It's not a Rockwell product. It's funded by Rockwell and all these competitors that are out there as well. So
yeah, that's one of the very unique things about Claroty in this space is Rockwell, Siemens, and Schneider are all investors in Claroty. They also utilize our products. So Rockwell and Siemens and Schneider actually utilize us in their facilities to protect their own equipment for production purposes. So it's, again, something very unique to Claroty in this space.
What's the sampling rate in which things are queried?
So if you're doing active queries, it's totally configurable. You can set it up to whatever you want. You can do them as frequently, or we have a lot of customers that do it on a weekly basis. Some do it on daily. Some do it even more than that. Everything I was showing off today was all passive, which means it's real time. So we see, the device generates the traffic on the network. We see it at the same time because we're getting a real-time copy of network traffic, and you would see it show up in the dashboard. So in that passive case, there is no sampling. We're processing all the data that's coming to us, and everything's happening in real time.
Okay, lots of questions here. So Claroty would need a traditional IT type of security protections ? I think that's referring to the software, the CTD, and things that are running. Probably is that what kind of protections do those need?
So it really depends. So like our device runs on a hardened OS. We actually run our own flavor. We call Claroty OS that restricts the operating system. We do a bunch of hardening on that. We do regular penetration testing and we have lots of security stuff I could go into a bunch of detail on if you guys want to do a follow up on that. As far as the rest of the environment, I mean, normally, I started with that. Normal IT security solutions typically don't work in these environments for a whole variety of reasons. So that's really why Claroty exists, right? We want to target this area. We want to be the solution provider for these operational and operational areas of your network.
Okay, another good one. Can we see historical data on alerts or other types of data that would have changed over time? So how is it stored in SQL Server databases, or is there other reporting methods, I guess?
You definitely can see historical data. So like in this case, this is all my open alerts, but you can come in here, a real system, you would have a lot more of these. You would have a long history of data. A lot of times we target this history to be like years of data because a lot of regulatory reporting requirements are in like the 2 to 3 year time frame. You can come in here and search. Again, I could look at let me just look at the last month of data. Let me just look at the alerts of a specific type, and maybe other advanced filters here on like what the assets are, things like that. You can also look for specific time frames. It's very flexible. You can really search against this however you want.
Okay. Can SNMP traps be configured in Claroty to end to pull details from a switch or other network appliances and hardware?
Yes, so we have a couple different ways of doing that. We actually have in our integrations, we have SNMP one automatically that will do, it actually crawls network infrastructure. So it'll go out to a switch, you input its SNMP information, it could be V1, V2, or V3. It'll hit that switch, gather the switch information. It also looks at what devices are plugged into what physical port, and it puts it on the dashboard. So you would see for a device that's plugged into this switch on this port. It'll also look at other switches. It actually crawls the environment for other switches as well. And then we have in our active queries, we have this idea of IoT matchers where you can create your own SNMP queries if you want. So if you're targeting like an IoT device, a camera or something like that we don't have support for, you can actually come in here and build an IoT matcher that's looking for specific OIDs, specific MIBs, and pulling back information on those. A lot of times Claroty will build these for you. In most cases we will. If there's devices that we don't support, we can add this on to add on SNMP support for a really wide variety of devices.
Okay, and one more here. For a company that's starting this industrial cybersecurity program, what would just be the first steps?
So I normally start with just trying to get an inventory, right? That's normally how we start with companies. I've seen a lot of customers building a program, and usually just wrapping your arms around the problem just starts with let's just get the inventory. Then it comes down to try and identify, your most critical assets. Usually it's safety systems or your most business critical stuff. Look at those, try and do things that we can do to reduce risk on those specifically, and then kind of slowly build out from there. I can tell you it is a journey. It is a long journey, and it is one that does not end like most things with cybersecurity, right? You're never going to pop the champagne and say we're 100% cyber secure. We don't have to worry about this anymore, right? There's always new stuff coming out. There's always new vulnerabilities. So it is an ongoing thing, but usually wrap your arms around the problem, try and identify your most critical systems. And again, usually that's safety stuff, business critical stuff. And then start there, use that to kind of figure out what your policies, procedures, response, that sort of stuff is going to look like. And then you can bake on top of it. I will say the good thing is Claroty has a lot of experience with this. You are not alone if you're just starting this. There are a lot of companies that are, cybersecurity and OT wasn't really a thing until probably 5-10 years ago. So there are a lot of people in your boat, and we are here to help, right? We've done this for a lot of customers. We really are there to help folks operationalize this and start moving the needle.
Thank you. That's looks like it's about it. And I will mention too that we do have a service available called Vulnerability Detection Service that uses the essentially this Claroty engine, and it's kind of a one-time run. It doesn't continually do the work that you see here, but it'll go out and you get those initial screens that you saw where it identifies the hardware and the vulnerabilities are there, and that's a possible first step too. That you could run some of this and then say, well, down the road I want to connect that to a constant threat detection engine and do it all the time, but it's a first step to see what the inventory is out there. So
yeah, I would be remiss if I didn't mention that working with folks like Rexel, like they also do this all the time, right? And they have much closer knowledge of your guys' specific systems, and they are really pros at this. So them helping to identify those first steps, I think, can really get you moving. And the tools that we have paired together, I think, make it really quick and easy to be able to do some of those first steps, get the ball rolling, kind of get it moving, and at the end of the day, reduce risk, right? Reduce risk, reduce exposure, start doing the security journey. That's really where we want to all get to.
okay. And one more request, I guess, for the PowerPoints. And if you want to send that to me, I can take care of getting those out. And I also want to mention too that the recording's available too for anybody that wants to share that with cohorts or fellow workers too as well. So.